Hey there. Ready for a deep dive into some seriously mind-bending AI?
I'm ready.
Okay, good. Because today we're tackling large reasoning models, those AI systems that are basically redefining problem solving.
Right?
We're talking AI that can write poetry, solve super complex math problems, debug code like a pro, and even design scientific experiments.
It really is incredible.
So what is the secret sauce? What makes these things tick? How are they so incredibly capable?
Well, it's really about how they're trained
Yeah.
and how they think about approach problems.
Hmm.
It's not just about size anymore. It's about the way they reason. OpenAI's O1 series is a great example. It's showing us a whole new level of AI reasoning.
Okay, OpenAI's O1, that name keeps popping up. What makes it so special?
Well, imagine a model that learns to reason like we do.
Really?
Yeah, that's what OpenAI has achieved. They use something called process rewards during training.
Process reward.
Yeah, it's like imagine giving the model a gold star for each step it takes towards the right answer.
Hmm.
This helps it break down problems step by step, systematically integrate, connect different pieces of knowledge,
Okay.
and even adapt to new situations that it hasn't seen before, kind of like a human expert would.
Wow. That's incredible. So it's not just about feeding these models tons of data, it's about teaching them to think strategically, like really strategically.
Exactly.
This process reward system sounds like a total game changer. Does this relate at all to the chain of thought prompting technique?
Oh, absolutely.
Okay.
Prompting is so important for guiding these models toward more sophisticated reasoning.
Mm.
Just telling a model, think step by step, can really unlock its problem-solving potential.
Mm.
And we're going beyond just chain of thought now.
Really?
Yeah, there are techniques like tree of thoughts emerging.
Tree of thoughts.
Yeah, where the model explores different reasoning paths, kind of like imagine branches on a tree, and it evaluates each path for the best possible solution.
Okay, hold on a sec. All this advanced training, sophisticated reasoning, it sounds incredibly computationally expensive.
Right.
Are we talking supercomputers running 24/7?
Well, that's a common misconception. Powerful hardware is definitely important, but researchers are finding ways to optimize the computation used, especially in the post-training phase.
Post-training.
Yeah, it's like fine-tuning the model's thinking process to be more efficient without needing to retrain it from scratch.
Okay, so it's not just brute force computing power, it's more about smarter algorithms and strategies.
Exactly.
Now, what about the open source world? Are there any projects out there that can compete with, say, OpenAI's O1 without the massive resources of a giant company?
Yeah, there are actually some really impressive open source efforts happening. OpenR, for example, is focused on replicating the reinforcement learning methods used in O1,
Mm-hmm.
and they're seeing fantastic results in areas like math problem solving.
Mm.
Then you have REST MCTS, which combines data collection and policy optimization into a single loop for more efficient learning.
That's amazing. So it's not just big tech leading the charge here. We have open source communities actively contributing to the advancements in large reasoning models.
Absolutely.
What are some of the key differences between the approaches taken by these open source projects?
Well, one interesting difference is how they create chain of thought data.
Hmm.
Those step-by-step solutions that help the models learn how to reason.
Right, right.
Traditionally, this was done manually by experts, which took forever and was super expensive.
Yeah.
But now, projects like REST MCTS are using the models themselves to help generate this data.
Wait, hold on. The models are learning from their own simulated reasoning processes. How does that even work?
No, it's actually pretty clever. They use an algorithm called Monte Carlo tree search, MCTS.
Right.
You might remember this from our discussion about tree of thoughts prompting.
Right, yeah.
So in this context, MCTS simulates different reasoning paths for a problem.
Okay.
And it uses a process reward model to pick out the best, the most promising ones.
Huh.
These successful paths then become training data for the large reasoning model.
So they're basically bootstrapping their own learning process.
Exactly.
That's brilliant. It feels like we're constantly discovering new ways to push the boundaries of what these models can do. So what's next? What are researchers focusing on to make these models even better reasoners?
Well, one area that's getting a lot of attention is test time scaling. It's about optimizing how well the model performs when it's actually solving a problem.
During inference.
Exactly. And what's really cool is that we're finding new scaling laws that suggest giving the model more time to think during inference, more computational resources, can significantly improve its accuracy.
Really?
Yeah, and we're not even changing its size or structure.
So it's not about building bigger models, it's about using their existing brain power more strategically.
Exactly.
Okay.
And there are techniques being developed to do just that, like using the process reward model, not just during training, but also during inference. It acts like a guide, steering the model toward the best reasoning paths.
So the process reward model is like a mentor, helping the model learn and also apply its knowledge effectively. That's a really interesting concept. How do these models explore all the different reasoning paths during this thinking time?
We'll use different search algorithms, each with its own pros and cons. One popular approach is beam search, which is kind of like exploring a maze.
Oh, okay. Tell me more about that. How does BeamSurf help these models navigate these complex problems?
Imagine you're at a fork in the road. You have to choose a path. Beam search keeps track of the most promising paths and explores them further, dropping the less likely options.
Okay, so it's about avoiding dead ends.
Yeah, it's about making the most of the model's thinking time.
Okay.
And then we have more advanced algorithms like look-ahead search.
Look ahead search.
Yeah. So while beam search looks at the immediate steps, look-ahead search takes a longer view.
Okay.
It simulates multiple steps ahead, using the process reward model to evaluate what might happen with each step.
So it's like playing chess, not just thinking about your next move, but planning several moves ahead.
Exactly. It helps the model avoid making choices that seem good now but could cause problems later.
It's really all about strategic thinking, isn't it?
It is.
This is really incredible. It sounds like the line between training and inference is getting blurred. Are these models essentially learning and adapting even as they're solving problems?
You're exactly right. And this is what makes large reasoning models so fascinating. They're not static systems. They're constantly
Yeah.
learning and evolving. It really challenges how we think about AI.
Hmm. This is really mind-blowing stuff. And it seems like OpenAI's O1 series is leading the charge in this area. What are some of the things that set it apart from earlier language models?
Well, OpenAI's O1 has made huge leaps, especially in its ability to use knowledge from different areas, different domains.
Hmm.
These models aren't just repeating information, they're actually synthesizing concepts and using them in new ways.
So it's genuine understanding then, not just memorization.
Exactly. It's the ability to make connections across different areas of knowledge.
Okay, that's impressive. How does this actually play out in real-world problem solving?
Well, one area where O1 excels is competitive programming.
Hmm.
These models can use their knowledge of algorithms and data structures to solve really complex problems, problems that require, deep logical thinking.
Wow, so they're not just crunching numbers, they're showing a more human-like way of understanding and applying these abstract concepts.
Exactly.
Are there any other examples of how O1 is putting its reasoning skills to the test?
Oh, definitely. Another area where O1 shines is problem decomposition.
Problem decomposition.
Yeah, breaking down complex problems into smaller, more manageable chunks.
Hmm.
It's a level of strategic thinking we haven't seen in other models.
So they're strategizing, planning, not just throwing computational power at a problem. This is incredible. It really does sound like OpenAI is onto something big with these human-like reasoning capabilities. Are these limited to O1, or are we seeing this in the open source world as well?
No, it's not just OpenAI. Remember OpenR and REST-MCTS. They're
Yeah.
showing us that these advanced reasoning models aren't just for big corporations. Researchers all over the world can experiment with and build upon these techniques.
That's fantastic news. It's great to see the open source community playing such a key role in making these powerful AI tools accessible to everyone. So what's next? What are the big challenges and opportunities on the horizon for large reasoning models?
Well, one area that's getting a lot of attention is evaluation. How do we know these models are actually reasoning correctly? It's not enough for them to just spit out an answer that sounds good.
Right, we need to know it's grounded in logic and understanding.
Exactly.
So how do researchers evaluate these models, and are there any aspects of reasoning that are still tough to measure?
There are a lot of things to consider. Like, can the model solve problems that involve multiple steps of logical deduction? Can it follow a chain of reasoning, apply rules and draw inferences to come to a valid conclusion?
So basically testing if they can understand and apply the rules of logic, like when we solve puzzles.
Exactly. And this is often tested with tasks like math problem solving, where the model needs to understand the problem, identify the relevant math concepts, and apply them step by step to get to the answer.
Okay, so it's not just about getting the right answer. It's about showing a clear, logical thought process.
Right.
What other aspects of reasoning are researchers focused on?
Well, another crucial one is their ability to integrate knowledge from different domains. Can they connect concepts and apply their knowledge in different situations?
So it's about being adaptable, flexible.
Exactly. And this is often evaluated with tasks that require the model to combine knowledge from different areas, like, say, applying physics to solve a biology problem.
Wow, so they're really pushing these models beyond just being specialized in one area.
They are.
It's about getting closer to more general intelligence.
Right.
What other challenges do researchers face when evaluating these models?
Another big one is testing their ability to handle different levels of complexity.
Hmm.
Can they maintain their performance as the problems get harder and require more complex reasoning?
It's like testing if they can level up their reasoning skills.
Exactly. So researchers often use benchmarks that include problems of increasing difficulty to see how well the model can adapt.
Okay, so we've got these different ways to evaluate reasoning, but how does it actually work? What do these benchmarks look like, and how do they measure the specific things we've been talking about?
Well, that's where a whole bunch of specialized benchmarks come into play. Researchers have created various tasks and data sets specifically designed to test different aspects of reasoning.
Okay.
One popular category is mathematical reasoning benchmarks.
Math makes sense. It's a field with clear rules and objective answers.
Exactly. It's a good way to test logical reasoning.
What do these benchmarks usually involve?
They cover a wide range of math skills, from basic arithmetic to advanced calculus, even theorem proving.
Wow.
And they often present these problems as word problems, so the model has to not only understand the math, but also the language and context.
Okay, so it's about bridging the gap between language and mathematical reasoning.
Right.
Are there other types of benchmarks besides math?
Oh, absolutely. There are also benchmarks for logical reasoning.
Hmm.
You know, like those classic logic puzzles where you have to figure out who's lying based on a bunch of clues. These
Yeah.
benchmarks often present scenarios where the model has to draw conclusions, identify inconsistencies, or figure out the next step in a logical sequence.
So it's about thinking critically and systematically.
Exactly.
What other types of reasoning are being evaluated?
Another important one is common sense reasoning.
Mhm.
These benchmarks focus on evaluating a model's understanding of everyday scenarios, social conventions, and how people generally behave.
Common sense reasoning, that seems like a tough one to evaluate. It's so much about understanding the little things, the unspoken rules of everyday life.
It definitely is. But researchers have come up with creative ways to assess it. Some benchmarks present scenarios where the model has to understand social conventions, predict what might happen next, or even detect humor and sarcasm.
So it's not just about math and logic, it's about understanding the nuances of human behavior. It's amazing how they're finding ways to measure these subtle aspects of intelligence.
It really is.
Common sense reasoning is a big part of human intelligence, and it's an area where AI has traditionally struggled. These benchmarks are helping researchers assess progress and develop models that can better navigate the real world.
Exactly.
Okay, so we've got benchmarks for math, logic, and common sense reasoning. Are there any other notable types that researchers are using to push these models even further?
Absolutely. Since these large language models are increasingly being used to generate code, there's a big focus on coding benchmarks.
Coding benchmarks.
Yeah, they assess how well these models can understand programming languages, generate correct and efficient code, and even debug existing code.
So they're not just writing poetry and solving math problems, they're becoming software developers too.
You could say that.
That's pretty impressive. What do these coding benchmarks involve?
They often present programming challenges or tasks that require the model to understand a problem's requirements, come up with an algorithm, and then implement it in code.
Wow, that's quite a challenge.
It is, and it speaks to the amazing progress that's being made in this field.
It really does. But with all these different benchmarks, I can't help but wonder, are they comprehensive enough? Can they really capture the full range of human reasoning abilities, or are there things that are still too difficult to measure?
That's a great question, and it's one that researchers are actively working on. While the existing benchmarks have been really helpful, there's always a need to develop even more sophisticated evaluation methods.
So what are some of the challenges researchers face in evaluating these models, and what are the potential directions for future research in this area?
One of the biggest challenges is capturing the dynamic and interactive nature of human reasoning. You see, a lot of the benchmarks focus on static problem solving. The model gets all the information it needs up front.
Right.
But in the real world, reasoning is much more fluid, We're constantly interacting with our environment, getting new information, and adjusting our thinking accordingly.
Right.
So there's a growing interest in benchmarks that better reflect this dynamic aspect of reasoning. Some researchers are exploring the use of interactive, game-like environments where the model has to make decisions, learn from its mistakes, and change its strategy over time.
Okay, that sounds like a much more realistic test of how well they can reason in a complex and ever-changing world.
Exactly.
Are there other areas where researchers are focusing their efforts?
Another big challenge is evaluating the model's ability to explain its reasoning. It's not enough for a model to just get the right answer. We want to understand how it got there. This is important for building trust and making sure these models are being used responsibly.
Right. If we're going to rely on them to make important decisions, we need to be able to understand their thought process and verify that it's sound. So, how are researchers approaching this challenge of evaluating explainability?
One approach is to require the models to generate explanations in natural language alongside their solutions. This way, we can see if they can actually articulate their thought processes and justify their decisions.
So, it's like asking them to show their work, not just give the final answer.
Exactly. And there are also methods that involve analyzing the model's internal representations, basically trying to understand how it's processing information and connecting different concepts. This helps researchers get a deeper understanding of how these complex AI systems actually work.
This has been such an interesting discussion. It's clear that evaluating large reasoning models is incredibly complex, and researchers are really pushing the boundaries here. We've talked about the training process, the innovative techniques for generating that high-quality reasoning data, and the different benchmarks used to evaluate these models. But I'm curious to learn more about the real-world applications. How are these models being used today, and what are some of the future applications that have researchers and developers so excited?
Well, that's where things get really interesting. The potential applications of large reasoning models are vast and incredibly promising. We're already seeing them being used in all sorts of fields, from scientific research to software development, even creative writing.
Let's dive into some specific examples. How are they being used in scientific research?
One area where they're showing a lot of promise is drug discovery and development.
Hmm.
These models can analyze massive amounts of biomedical data, identify potential drug targets, and even design new molecules with specific therapeutic properties.
So they're helping to accelerate the process of finding new treatments and cures for diseases.
Exactly. And it's not just drug discovery. They're also being used to analyze complex scientific data in fields like physics, astronomy, and climate science, helping researchers make new discoveries and better understand the world around us.
That's amazing. And what about software development? How are these models helping to write code and build software?
Well, we're already seeing them being used to automate certain coding tasks. Things like generating boilerplate code, translating code between different programming languages, and even suggesting code completions as developers are writing.
So like superpowered coding assistants.
Exactly. And some researchers are even exploring the possibility of using these models to generate entire software programs from natural language descriptions.
Wow.
That can completely change how we develop software.
That would be a game changer. You mentioned creative writing earlier. I'm curious to hear more about how these reasoning models are being used creatively.
Well, they're not just limited to logic and analysis. They're also being used to create things like stories, poems, even screenplays.
So they're becoming authors, poets, screenwriters.
You could say that. Of course, there's still a lot of debate about the role of AI in creative fields,
Yeah.
but it's clear that these models can generate some pretty impressive and imaginative text.
This is also fascinating. It feels like these large reasoning models are popping up everywhere, changing the way we work, learn, and even create.
It's a really exciting time to be following this field.
It is.
And as these models keep evolving, we're going to see even more innovative and impactful applications emerge. I think they're going to shape the future of countless industries.
It's amazing to think about how far we've come. We've gone from basic rule-based systems to these incredibly sophisticated models that can reason, learn, and even create.
It's a remarkable journey.
It is. But with all this progress, it's also important to consider the ethical implications and potential risks. As we move forward, how do we ensure that these powerful models are used responsibly and for the benefit of all?
That's a crucial question, and one that we'll delve into further in part 2 of our deep dive.
Okay, well, stay tuned, folks. We'll be right back after a short break.
So, picking up where we left off, the next 5 to 10 years are going to be huge for large reasoning models.
Really?
Yeah, I think so. We're already seeing them taking on problems that, used to be considered way too complex for anything but a human expert. But as they keep evolving, their impact is only going to get bigger.
Okay, I'm intrigued. What areas do you see the biggest advancements, the biggest impact happening in the next few years?
Well, healthcare immediately comes to mind.
Healthcare.
Yeah, imagine these models helping doctors diagnose diseases with incredible accuracy.
Hmm,
Personalizing treatment plans based on each patient's unique data,
right.
and even speeding up the discovery of new cures.
That would be revolutionary. It's amazing to think they could play such a crucial role in improving people's health and well-being. What other fields are likely to be really transformed by these advancements?
Well, education is another one that's ripe for disruption. Imagine personalized learning experiences for every student.
Hmm.
AI tutors providing guidance and support at every step.
Okay.
These models could make education more accessible, engaging, and effective for everyone, no matter their age or background.
That's a powerful vision. Personalized education could completely change how we learn.
I think so.
And it seems like these large reasoning models are poised to have an impact on almost every aspect of our lives.
Oh, absolutely.
Yeah.
And we can't forget about scientific research.
Right.
These models could analyze those massive data sets, identify patterns that we might miss,
Mm-hmm.
generate hypotheses, things that would take human researchers years to figure out.
Right.
They could really speed up discoveries across so many scientific disciplines.
Okay, that's pretty mind-blowing. It's like having a team of super smart researchers working alongside scientists.
Wow.
What a powerful combination. But with all this potential, we also have to think about the challenges, right?
Oh, absolutely. The potential benefits are huge, but we have to be realistic about the challenges too.
Hmm.
One of the big ones is ensuring these models are robust, that they're reliable.
Okay.
We need to be confident they can handle unexpected inputs, deal with ambiguity,
Mm.
make decisions that are safe and ethical in all sorts of real-world situations.
That makes sense. We can't just unleash these powerful models without some safeguards. How are researchers addressing these challenges? How do we make sure they're used responsibly and effectively?
Well, one approach is to focus on transparency and explainability.
Transparency.
Yeah, it's not enough for them to just spit out an answer. We need to understand how they got there, what
Wow.
factors influence their decision,
Hmm.
whether there are any biases we need to be aware of.
Right, so it's like asking the model to show its work so we can understand its reasoning and spot any potential problems.
Exactly.
That's so important for building trust and making sure they're used ethically. What are some of the specific ways that researchers are trying to improve transparency and explainability?
Well, one way is to actually require these models to generate explanations alongside their solutions.
Okay.
Like they have to explain their reasoning in a way that we can understand.
So they're not just giving us the answer, they're telling us how they arrived at it.
Right.
Okay, that's fascinating. What other methods are researchers using to understand these models' decision-making processes?
Another promising area is developing ways to visualize and analyze the internal representations of these models.
Okay.
So, being able to see how the model is processing information, what connections it's making,
Hmm.
how its understanding evolves as it's working through a problem.
It's almost like we're looking inside the model's brain to see how it's thinking.
Exactly.
And that's crucial for identifying potential biases or understanding how they really work.
It is. And as these techniques get better, they're going to be crucial for making sure these models are used responsibly.
It's really amazing how much progress has been made in such a short time. What are some of the research breakthroughs that have made this rapid advancement possible?
Well, one of the big ones has been the development of new training techniques, especially those using reinforcement learning and process rewards.
Right.
These approaches have allowed researchers to train models that can actually reason more like humans, breaking down problems into steps, learning from mistakes,
Hmm.
constantly refining their problem-solving strategies.
It's incredible how these training techniques are mirroring the way we learn and reason. What other innovations have been key to this progress?
Another big one has been the development of more efficient search algorithms, like beam search and look-ahead search.
Right, we talked about those earlier.
Exactly. These algorithms help the models explore all those possible solutions more efficiently, making strategic decisions and avoiding those dead ends.
It's like giving them the ability to think strategically, plan ahead, like a chess player.
Exactly.
Okay, and those advances in search algorithms, have they been coupled with any other advancements in, say, hardware or software?
Oh, absolutely. The availability of more powerful computers, along with the development of specialized software tools, has made it possible to train and use these massive models, pushing the boundaries of AI even further.
So it's really been a combination of factors that have led to this incredible progress.
It has.
It really is an exciting time to be witnessing this technological revolution unfold.
It is. And I think as these trends continue, we can expect even more breakthroughs in the years to come.
Really?
Yeah, larger models, more efficient training methods, even more sophisticated search algorithms. All these things will continue to improve the reasoning abilities of these systems, opening up all sorts of new possibilities.
Okay, that's pretty fascinating. What areas do you think will see the biggest impact from these future advancements?
Well, one area I'm really excited about is the potential for these models to become even more creative.
Creative. Yeah.
While they've already shown they can generate things like stories and poems,
Mm-hmm.
I think we're just scratching the surface of their creative potential.
That's an intriguing thought. How do you see these models becoming even more creative? What kind of breakthroughs would need to happen?
Well, one key area is developing training techniques that encourage exploration and experimentation.
Okay.
Right now, most models are trained to produce outputs that are, very likely inconsistent with the data they've been trained on.
Right.
But real creativity often means breaking away from conventions, exploring new ideas,
Mm.
producing something that's surprising and unexpected.
So, pushing these models beyond simply mimicking human creativity
Exactly.
into a space where they're generating truly original ideas.
Right. So one promising approach is to incorporate mechanisms that reward models for coming up with diverse and surprising outputs,
Okay.
like using reinforcement learning techniques that encourage them to explore those less traveled paths,
Hmm.
rewarding them for generating something that's both novel and relevant.
It's like giving them a nudge to think outside the box.
Exactly.
What other breakthroughs could help unlock that creative potential?
Well, another important area is developing better ways to evaluate creativity.
Hmm.
Right now, a lot of the metrics we use rely on simple statistics, but those can miss the subtle aspects of human creativity.
Right.
Things like evoking emotions, telling a compelling story, or expressing a unique perspective.
Okay, so it's about going beyond just the technical aspects of creativity and really trying to capture what makes something truly creative.
Exactly. So one promising direction is to actually incorporate human judgment into the evaluation process,
Right.
like using crowdsourcing to get feedback on how creative and original the model's outputs are.
So bringing in that human touch to make sure we're not just measuring technical skill, but also the essence of what makes something creative.
Exactly. And as these techniques evolve, I think we'll see a real explosion of creative output from these models. We might even see them generating music, art, and designs for physical objects.
That's an incredible thought. A world where AI systems are collaborating with human artists and designers to push the boundaries of creativity in every direction. What are some of the other areas where you see these advancements having a big impact?
Well, beyond creative fields, I think they're also going to be huge for boosting human productivity and decision-making across all sorts of industries. Imagine AI assistants that can not only automate routine tasks, but also give us really insightful recommendations,
Oh, right.
anticipate potential problems,
Hmm.
help us make better decisions in those complex situations.
It's like having a brilliant partner working alongside us,
Exactly.
augmenting our abilities, helping us navigate this increasingly complex world. Can you give some specific examples of how these AI assistants could change things?
Sure. In business, for example, we could see these models analyzing market trends,
Hmm.
identifying new opportunities, personalizing marketing campaigns.
Right.
They can even help with things like scheduling meetings, drafting emails, summarizing complex documents, freeing up human employees to focus on more strategic, creative work.
That's pretty amazing. What about other areas?
Well, in healthcare, AI assistants could help doctors diagnose diseases more accurately, recommend personalized treatments, and keep track of how patients are doing.
Hmm.
They could even help researchers find promising new treatments by sifting through tons of medical literature.
It's really incredible to think they could have such a big impact on healthcare, improving patient outcomes, potentially saving lives.
Absolutely. And in education, they could create truly personalized learning experiences for every student,
Okay.
providing that targeted feedback and support to help them learn those difficult concepts.
Right.
They could even help teachers design better lesson plans, freeing up more time for them to focus on individual students.
So it's like having a personal tutor for every student.
Exactly.
That's incredible. And beyond those specific applications, do you see any bigger picture impacts from these models?
Oh, I think they have the potential to completely transform how we interact with information and technology in general.
Hmm.
Imagine a world where we can talk to our devices naturally, ask complex questions and get detailed answers, even collaborate with AI systems on creative projects.
Wow.
It would be this seamless blend of human and artificial intelligence.
That's a captivating vision. A world where technology really adapts to our needs and helps us achieve more than we ever thought possible.
Exactly. But as we move towards that future, it's important to do so carefully.
Right.
We need to be aware of the potential risks, the ethical considerations.
Hmm.
Make sure these technologies are used for the benefit of everyone, not just a select few.
That's a crucial point. As we explore the potential of these models, we need to think about the ethical implications and the impact on society. So, in the next part of our deep dive, we'll explore those critical considerations and discuss how we can navigate the challenges and opportunities ahead. Okay, we've covered a lot of ground in this deep dive. It's it's amazing to think about just how far large reasoning models have come,
Okay.
and the incredible potential they have.
Yeah, absolutely.
But like with any really powerful technology, we need to be aware of the potential downsides. Proceed with caution.
Right.
What are some of the challenges we face as we integrate these models more into our world?
Well, one of the biggest concerns is definitely control and unintended consequences.
Hmm.
These models are so complex, it can be hard to fully understand, or even predict exactly how they'll behave in every situation.
Right.
There's always the risk of them doing something unexpected or generating outputs that are biased or even harmful.
Yeah, that makes a lot of sense. We've seen this with other AI systems where unintended biases have crept in and led to some unfair or discriminatory outcomes. How can we make sure that large reasoning models are developed and used in a way that minimizes these risks?
Transparency.
Yes.
Transparency.
Yeah, we need to understand how these models are trained, what data they're trained on, and how their decision-making works. The more we understand, the better equipped we are to identify and fix any problems.
Okay, so it's about understanding how these models work, really lifting the hood and taking a look inside.
Exactly.
What are some specific steps researchers are taking to make sure these models are developed responsibly?
Well, one important step is to create really thorough documentation.
Okay.
Something that outlines the whole training process, the data sources, the model's architecture, all of it.
Okay.
This documentation helps everyone understand how the model was built and identify areas where biases might have snuck in. Okay, so it's like a blueprint of the model that allows for scrutiny and identification of potential issues.
Right.
What else are researchers doing to promote responsible use?
Another crucial step is to have rigorous testing and evaluation procedures.
Hmm.
It's not enough to just train a model and let it loose in the world. We need to test these models in lots of different situations,
Mm.
see how they perform on various tasks, and make sure they can handle those unexpected inputs or really tricky situations.
It's like putting them through their paces.
Yeah, exactly.
What are some of the challenges with testing and evaluating these really complex models?
Well, one challenge is that those traditional evaluation metrics, they don't always capture the whole picture when it comes to reasoning.
Okay.
Just measuring how accurate they are on a data set might not tell us how they're actually reasoning or if they can handle new situations.
So it's not just about getting the right answer. It's about how they get there, if their thought process makes sense.
Exactly.
So how are researchers dealing with that? Developing better evaluation methods.
Well, one approach is to create very specific evaluation tasks that target different aspects of reasoning,
Okay.
like, their logical deduction skills, their common sense reasoning, or their ability to put together information from different places.
Mm.
These tasks can give us a better idea of what the model is good at and where it might struggle.
Okay, so it's like having a more specialized testing process.
Right.
What other innovative approaches are being used to evaluate these models?
Another interesting direction is to actually bring in human judgment.
Mm.
This could involve having experts look at the model's outputs, judge how well it's reasoning, and give feedback that can be used to improve the model's training.
So it's like having human experts as mentors or judges for these AI systems.
Exactly. And I think as these evaluation methods improves, we're going to see much more reliable, large reasoning models, models that we can really trust to perform those complex tasks and make good decisions.
Well, this has been a truly fascinating exploration of large reasoning models. We've talked about their capabilities, their limitations, and the potential impact they could have on our world. As we wrap up, what's the one key takeaway you hope listeners will walk away with?
I think the biggest takeaway is that large reasoning models are a huge leap forward in AI.
Hmm.
They're doing things we never thought possible before, and the potential benefits are just incredible.
Right.
But it's really important that we approach this technology carefully. We need to be aware of the risks, the ethical implications, and work together to make sure these powerful tools are used for good.
That's a great point to end on. Large reasoning models have the power to change our lives in so many ways, but it's up to us to guide their development and use responsibly. It's been a pleasure diving deep into this fascinating topic with you.
The pleasure was all mine.
And to our listeners, thank you for joining us on this journey. We hope you found it as thought-provoking as we did. Until next time, keep exploring the incredible world of AI.